This is a total production. Alright, y'all, this will be our last video for Chapter 3 practice, or at least our fifth one. And so this is looking at more chair conformations, where given a chair conformation, can you give the IUPAC name? Can you perform a ring flip? Can you determine is the original or the ring flip more stable, which one? And then also drawing a top-down view. Alright, so from this first one here, what would be the IUPAC name for it? Well, it's got two methyl groups on it. So we would call this based off the numbering, 1, 2, 3, 4, we'd call that a 1,4 dimethyl cyclohexane. But also from here, you notice this methyl is axial up and this methyl is equatorial up. So since they're both up, right, on the top face of the ring, we would also have to put in whether it was cis or trans. So they're both up, so we would say that this is cis. Okay, so cis 1,4 dimethyl cyclohexane. Now, in performing the ring flip, what you do is you kind of draw the mirror image of this ring. So the chair here looks kind of like this. If I draw, I can't draw it as pretty as this structure is. So the mirror image would look like so, something like that. Okay, like this demented looking lightning bolt. All right, even though that's supposed to be a chair conformation. All right, so from here, what you're going to do is you're either going to rotate every carbon one position clockwise or one position counterclockwise. So in rotating, I'm going to rotate everything clockwise. So I'm going to label this one as the dot, so it would go here, meaning it's going to be in the bottom middle. So that would be this position right there. And then I'm going to rotate this one the same direction, one position there. So now it'd be in the top middle. So right here. Alright, now what's up stays up, what's down stays down. Pretty much what you'd have to do here is you're going to see that the methyl here was axial up, so now it's going to be equatorial up right there. Here it was equatorial up, so now it's going to be axial up, so right there. Now, based off this, right, it wants to know which one is more stable. If you notice, you've got the equatorial groups are pretty much, we think of them as just zero energy, right? They're not really affecting the stability at all. It's only axial positions that alter the stability. So with that, we have an axial methyl that's making it unstable, and then we have an axial methyl. It's this one now, right? But it's a different axial methyl that's making it unstable. So really, there is no difference in stability. So they have equal stability. Okay. Now, it wants us to draw the top-down view. So when you draw a top-down view, kind of the easiest way I show students to draw it, so that's the original one. I'm just hand drawing it. So when you draw the top-down view, I'd say look at this top middle position, right? And draw your hexagon. Okay? So that top middle is that top middle. And so if it is up, right, that means it's pointing on the top part of the face, right? It's pointing upwards at us. So when I would go to draw this, I would say, all right, well, there's a methyl if I go one position counterclockwise. So there's a methyl there, right? That would be one position counterclockwise. And then there's a second methyl 1, 2 positions clockwise. So 1, 2. There's a methyl there. Now, since they're both pointed up, I would have to give them wedges. Okay, so that would be more consistent with kind of how we would see it. All right, next up we have this hydroxyl group, and then we have a methyl. So this is hydroxyl, and this is methyl. So when we go to name it, right, what gets the higher priority, the H or the M? It's going to be the H. So that's going to be 1, 2, 3. So I should name this 1 hydroxyl, 3 methyl, and I'm running out of room, so I'm going to have to continue down here, cyclohexane. All right, now also we have to put in if it's cis or trans. If you notice, this one is axial up, this one is equatorial down. So they're on opposite sides of the ring, opposite faces of the ring. So I'd actually have to put trans at the beginning of the name. So that's a trans 1-hydroxyl 3-methyl cyclohexane. All right. Now in doing the ring flip, right, it looks like the original view for this is something like that. So we have a hydroxyl that's axial, a methyl that's equatorial. All right, so remember when we do the ring flip, we draw the mirror image of this chair. So I would start by drawing it like that. Okay, so that's sort of like the mirror image. Okay, then I'm going to rotate it. So I rotated this top one clockwise. I'll rotate it counterclockwise. So that means this would move here, right? So the dot carbon would now be right there. And then the circle carbon would move that way. Okay, so it's going to be here on the bottom right corner. So there's the circle. All right, now if you notice, right, if it's up, it stays up. If it's down, it stays down. What you're going to swap is the axial and the equatorial nature of everything. And so here you have an OH that's axial. So now it's going to be equatorial up, OH. Okay, because you have an axial down hydrogen, so I'll draw it. And then here it was down, so now it's going to be axial down. All right, now if we evaluate this, we have either a hydroxyl that's axial or a methyl that's axial. So in terms of stability, the big thing to remember is nonpolar groups like alkyl chains, they make it less stable. Okay, polar groups are a-okay to they're not a-okay. They're better scenarios to be axial. So when you have to choose between a polar group axial or a methyl group axial or an alkyl group axial, you're going to want the the hydroxyl one, sorry, the OH group. You're going to want that axial. So that's actually the more stable, the original one that we were given. That's the more stable chair conformation. All right. Now, in terms of showing the top-down view, remember, I'm going to redraw this again. So when we redraw it, it was the methyl down and then the OH up. So I said, take that top middle portion, put a dot there, right? That's going to be the same thing as when you draw the hexagon, right? You're going to have that top middle dot right there. Okay, so if I take one step clockwise, I've got a methyl pointed down. So one step clockwise, I'll have a methyl, but to point it down, I need a dash. Okay. Now from that dot, if I take 1, 2, 3 steps counterclockwise, so 1, 2, 3 steps counterclockwise, I'll have the OH here, right? And it was up. So in pointing it up, that means it has to have a wedge. All right. Up is wedges, down is dash. Okay. All right. Next, I have 2 equatorial groups. I have a methyl and an ethyl equatorial group. So E versus M, that means this is carbon number 1, 2, 3, 4. Okay, so it's going to be 1 ethyl, 4 methyl, cyclohexane. Okay, and then we have to look, are these cis or trans to one another? To do that, it would be easier. Go ahead and start drawing some axial positions. So that'd be axial up, that'd be axial down. So this is equatorial up. So if this is axial down, this is axial up at the 1 position. So this is equatorial down. So one's up, one's down. So that means it has to be trans 1 ethyl 4 methyl cyclohexane. All right. Now when I do the ring flip, right? So drawing the mirror image like so. Let's go clockwise. So my methyl here is going to hop to there. So it was up, it's going to stay up. So to be up, it's axial up. That's my methyl. My ethyl is going to pop to over here, right? Because I'm going the same direction clockwise. So now it was down, it's going to be equatorial down there. So there's my methyl, there's my ethyl. So what do I have? 2 equatorials versus 2 axials. Axial's a bad position. So my original one is my most stable one. I didn't do this on purpose, but the original one I drew was the more stable one. Okay. Now in terms of drawing the top down, let me redraw it over here. So if I redraw what I started with, you're gonna have in the top middle your methyl, and then in the bottom middle you're gonna have your ethyl, and they're both down. This one's up, axial up, and then this one's equatorial down. Alright, so when I draw it, write the dots. Alright, so there's my top carbon, my top middle, and then here's my bottom middle. Alright, so I'm going to have a methyl that's up there. So to be up, it's got to have a wedge. And then here I'm going to have an ethyl that's down. So let me draw an ethyl group. Alright, and that has to be dashed. Down is dash. Down is dash. Alright, and then our final one. Here we've got a bromo and a fluoro group. So this is equatorial down, this is equatorial up, right? Because if I draw the axial position, right, axial up, axial down, those are my hydrogens. So it's a bromine and a fluorine. So what comes first in the alphabet, B or F? It would be B. So this would be position 1, this would be position carbon 2, all right? So one's up, one's down, so I automatically know up and down, right? They're on opposite faces, it's trans. And so it would be 1 bromo, 2 fluoro, cyclohexane. All right. Then in doing the ring flip, right, I'll put my dot here. That means now I'm going to have my bromine in the middle, and then my fluorine's going to go up there. So let's draw that mirror image. So it should look something like that. There's my demented looking lightning bolt. That lightning bolt looks tired. Alright, so anyway, so my bromine is going to be down in the middle, right? It was equatorial, so now it's going to be axial down. Bromine's down. Here it was equatorial up, so when it moves up to here, right, it's going to be axial up. Okay, so if it's up in the first one, it's up in the second one. All you're ever changing is the axial and equatorial positions. So what do we have? 2 equatorials, 2 axials. Axial's less stable, so that's going to be my more stable chair conformation. All right, now in terms of drawing my top-down view, remember I got my dot here in the middle, so I'll draw my hexagon, my dot right there in the top middle. So I'm going to have a bromine here and a fluorine there. So let me draw the bromine, let me draw the fluorine. Alright, now this one's down. Remember, down means dash, so my bromine needs a dash. My fluorine here was equatorial up. Up means it's a wedge. Okay, so the big takeaway here on these top down views is that the axial equatorial doesn't give me the dash and the wedge. It's the up or downness that gives me the dash or the wedge. Alright, so hopefully this helps and you feel even more comfortable with chair conformations, doing the ring flips, and even naming if you're given a chair instead of these top-down views. Alright, adios.